I'm going to take you on a journey that I went through myself a few years ago when I discovered functional JavaScript. So this is going to be a light introduction to functional JavaScript through the functions of map, filter, and reduce. So the thought I want to lead with today is that for loops are broken. Now, we all have for loops in our code. I have for loops in my code still. You probably still do too. And there are definitely situations where you need to use them. However, JavaScript has provided ways for us to become less dependent upon for loops because that it's a lot of generic code that isn't reusable and makes our code not as easy to read. And as has been said today, we spend more of our time as developers reading than we do actually writing code. So this journey all started with this wonderful code you have behind me. It's 50 lines of code doing 5 things. This code is essentially parsing a response from the Smartsheet API. But as I made this code, I was done with it, and I thought, wow, that's really nice. And then I showed it to a friend who was a little more experienced than I was with functional programming, and he said, yeah, you could clean that up a bit. So I said, of course I can. How? And so I went and I learned more about map, filter, and reduce. So to give you a little bit of background about Smartsheet, just because it's the subject matter of half of what I'm talking about, because we're talking about Smartsheet API responses. It's a work collaboration platform. Essentially, think of a spreadsheet in the cloud. I hate that term. Spreadsheet online. 2 things I'm not allowed to say. But anyway, it's essentially a table of data. You can track any type of work. People track projects. In this situation, we're tracking customer lists where they're making orders, and we track the status of the orders and things of that nature. So when you think of an API response, a JSON response of this table, you're going to have a JSON object with an array of columns. Then you're going to have an array of rows. And inside of each of the rows, you're going to have an array of cells with more objects. So when you write code to parse through all of that, initially, if you don't know about functional programming, you're going to be writing a lot of loops for some loopy code. So Smartsheet can be used for lots of different things. But for me, and this code you saw previously, it was a little more personal situation. I come from the McAllister clan, and my branch of the family comes from the Midwestern section of the United States, where in that area of our country, offspring is a currency, and my parents were wealthy. We came from a family of 6 kids, and now we're all grown adults, and we all have kids of our own, and none of us have anything less than 3 kids. I even have a sister who has up to 7, I think. So if you think about that from my mom's perspective, that's a lot of birthdays to keep track of. Every time someone's birthday comes up, she may miss a birthday or 2. So I was thinking about her predicament one day, and I thought, oh, Mom, I could create a sheet for you. And this is a simplified version of the sheet, because I didn't have their permission to use their likenesses, with their addresses, things of that nature. But we kept track of their names, a birth date, and their age. Not necessarily for me or for my parents or for my siblings, but more for the nieces and nephews, right? So you know who's 13 and who's 21, things of that nature. You can change your birthday card. This was awesome. It sent out an automated reminder 2 weeks before everybody's birthday, and Mom was happy, I was happy, the whole family was happy that they were getting birthday cards from Mom. Until the end of the year when I made this. December 31st rolls around, and then the year goes up. But all these reminders, all these birth dates, are dates. And the sheet doesn't update dates. So my sister-in-law, whose birthday's on the 2nd of January, wasn't very happy when she didn't get a notification or an email or a birthday card from my mom. And I was in trouble because it was my thing, and it was supposed to be this wonderful thing. So what happened is I thought, as I was going through, typing in the years of each of the people, updating the years, my fingers were thinking, this is not something for fingers to be doing. This is something that code should be doing, because we're all developers. We don't think that, we think that the less work we have to do, the better. The more work the code does, the better. So that's when I created this code here. It's basically finding the birth date column, then it's going over all the rows in the sheet, finding the cell with the birth date column ID, updating the year if it's in the past, and then submitting it to the Smartsheet API. Again, 50 lines of code to do 5 things. So the problems, as I've talked about, is that a lot of code, it's hard to test, and it's generic, not really reusable. But JavaScript has evolved over the years, and with the rise of functional programming languages, it's actually picked off the low-hanging fruit of functional programming. As I mentioned, we'll talk about 3 of those functions that they've built into the arrays object. We'll talk about how to use them, when to use them, not so much on the theory, because really, what's a monad anyway, right? So let's look at a for loop. This for loop has an array of people. It's going over that array. It's checking to see if the age is greater than 18, and then taking those people and putting them in an adults array. Simple enough. But out of the 5 lines of code, this is really the only part that's unique to our situation. All the rest is just generic looping code. So what if we took that same condition and just applied a filter to that people array? So we take that piece, stick it in our callback function we have for our filter, and suddenly we have a filter where we're filtering the people that are over 18 into the adults array. 5 lines down to 1, and as we're reading through it, as we're starting to see the pattern of what to look for, it becomes a lot quicker to read and easier to read. Let's look at another array. In this situation, we have a simple numbers array, 1, 2, 3, 4, 5, and we want to double each of the values in the array. So we take the number for each element, we multiply it by 2. Now if we did that with a map, we can take a map on the nums array, take that same equation that we have in our for loop, apply that to each element in our map or in our nums array, and then create our dubs array. So the maps, what it does, rather than filtering out, filtering takes elements out of your array that are based on a certain criteria. Maps actually perform an operation on each element in your array. So we're performing that operation of the equation to create the dubs array, all in a single line of code. And as I mentioned, I'm going to say this a lot, once you start seeing the pattern, you can see the pattern of how it works, it becomes really easy to read. Now reduce is a different bird altogether. Map and filter, they created new arrays based on the current array, but with reduce, we're taking the array and reducing it down into something else, either an object or a number or just a single value. So what we're going to do here is we have our simple array of 5 numbers, and we want to total them up to create a single sum. Our equation here is simple. We take our sum, we're adding the element, and then thus increasing the sum. But with the filter, we'll take that same equation, reduce. We'll take that same equation, but instead of only passing in just the element, so just the num, we're also passing in what's called an aggregator value for total. That total value is initialized here as the second argument in the array, in the function. And that's important in that in this situation, we're creating a number. In other situations, you might be reducing your array into an object. So if you were going to initialize an object, you'd want to put your curly brackets down there. So in this situation, though, we're just making a sum total. So we're taking the total. The total is incremented or added to by the num element that comes through, and is reduced to a single sum value. And so that is the pattern of reduce. Let's step it up just a little bit more, because honestly, how often in our code do we have an array of integers that are simple to look at? And oh yeah, I just want to make a sum, right? So let's look at something a little more, slightly more complicated. Here we have, ooh, that is small. Better? And it's dark, sorry about that. So I have an array of people, and it's our family, the Simpson family. We'll make it a little bit more. I would do it with hotkeys, but for some reason my hotkey doesn't work. Anyone want to tell me why later? That'd be awesome. So I have my Simpson family. I have Bart, Lisa, Maggie, Marge, and Homer. They all have ages, 10, 8, 36, 1, and 39. What I found out when I did all of this was realizing that I'm really close to Homer in age, and that kind of messed with my head a little bit. So with the Simpsons, what we want to do is they have a local establishment in their town of Springfield called Moe's Tavern. Moe's Tavern can only allow people of 18 age or over to drink. So we want to find out who in the family is of drinking age in Springfield. We have our array of people. There is our condition here. And then after that condition is met, if they meet it, they get put into the adults array. We can even see that it works here. So Marge and Homer are the only legal members of the family who can drink, even when Bart approaches Moe with a fake ID. Now, let's try our new way that we've been talking about today, where instead of looping over our people array, we're actually going to apply a filter. So the people, we're going to apply a filter. We'll take the same condition that we had in our loop and then put them in the adults array. We'll run this again. Hold on. That showed the same thing because it was the same thing. I didn't save. But still, it shows the same thing even though I did it at the bottom of my screen. So a little bit more real-world situation when we start dealing with objects. Now, the next thing we're going to do with the Simpson family is we're going to age them. After 30-some-odd years of being on TV and not aging a day, the network has decided that they need to increment their age. So what we're going to do is we're going to increment each age by 1. In our old loopy way, we have our for loop. We have our person object, we set our name, we take the age, we increment it by 1, we add them to the pushed, or we push them to the aged array. There we go. Bart is now, whoops. Let's do this. Da, 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 da. Bart is now 11, Lisa's 9, Homer's 40. Poor guy. And then I wonder if his joints feel as good as mine do. And then, so let's instead of looping, we're going to apply a map to each member of the Simpson family. We'll do the same thing that we were doing down here in our loop, where we create the new object with the name and the age plus 1, and then we put those into the aged array. We'll save it this time. Run our map, file, and still get an increase in age. Now, the last thing we're going to do with the Simpsons is we're going to find their average age. We're going to do that with reduce. To find the average age, we want to total up all their ages, right? And then we'll divide it by the number of members in the family. In our for loop, we find our total age, divide it by the number of people, run it just to make sure that works. And the average age of the Simpson family is 18.8. I think Maggie brings it down a lot for Homer and Marge. Here we go. So instead of that way, we're going to try our functional way. So here we have our people. We're reducing. Remember how we have our aggregator value of total age, which starts at 0. Then for each element, we're going to take their age and add it to the total age to find the total age of the whole family. And then we'll take that value, put it over the number of people in the family to find the average age. I saved it, we're good, it runs, and it's still the same value. So hopefully that helps see the patterns of map, filter, and reduce just a little bit better. We're going to go back to my real world situation. All right, that's showing up better than I expected. That's good. So on the right, we have our functional approach of my code, and on the left, we have the looping code. And still, after learning about the building blocks that we just discussed, I'm sure the stuff on the right still looks a little complicated and a little scary, as it did the first time I learned it. But let's look at each of the things, each of the pieces, and see what is going on. So first, we're finding our birth date column. On the left, we see the for loop. It finds the column with the column name. So on the right, we still do the sheet columns. We grab that array. We filter it based on the date column name. And then inside of a map, we set a value called date column ID that we're going to use in the rest of the code. Here is where we find all the rows in the sheet that we want to update. Because when you update a sheet, or update any cells in a sheet, you have to update an entire row. You send the update there. So what you do is we're going to perform a map on the row, because we're going to look at each row and perform an operation. And then inside that row, each row needs an ID, and then each row needs cells. So we'll look at the cells, and we'll filter out all the cells that have the same column ID as the date column ID, and where their date is less than a week ago. Side note on the week ago bit. Where I'm running this code, the times between that server and the Smartsheet server weren't consistent, and they weren't staying consistent, so I couldn't keep it right on the day. So birthdays happen once a year. I figured it's OK if it checks it or changes it a week after the birthday. So that's why we have the week ago. So once we find the cells that we want to change, in the map, we perform the operation where we update or increment the year on that cell. And then once we're done parsing through through all the rows, we want to make sure that we're only sending rows to the API in the update request that actually have changes in them, that actually have cells in the row. So we want to filter out all the rows that don't have cells and only include the rows that do. And of course, I'm sure you're wondering, does this really work? So let's look. Here I have my sheet. And no, this is not fake data. That's my family. In fact, as I was looking at it last night, this actually isn't my whole family. One of my sisters actually had another child that's not included on this. So there's a lot of kids to keep track of. As you notice here on my dad, his birthday has already happened. It's January 31st. So we're going to have our code over here, where we're going to increment our year. We'll increment the function version. Then we're going to get a big response back from Smartsheet that doesn't matter to us today. It just lets us know that something happened, and that's the result that we have. I'm going to refresh my sheet. And there, my dad's birthday updated. He's happy. I'm happy. My mom's happy. So she'll remember his birthday next year. Because, we don't want her to forget her husband's birthday. So all these examples I've been showing you have been in Node and running on the server. If you're going to do this in the browser, you want to keep browser compatibility in mind. This is a simplified table of what I could find as far as compatibility. Mozilla on MDN has a great compatibility table that you can also look at that has more in-depth and in detail compatibility alignment. So be sure to make sure that it works for what you need to do as far as which browser you're running in. This is just an introduction. as you dig in more to map, filter, and reduce, go ahead and check out the MDN articles at these links. I'll tweet out the slides after the talk, so you can go see and dig in more on how to use map, filter, and reduce. And also, if you want to look at the code we were just going through with the incrementer, you can also find multiple versions of that code there, where I'm doing it with the functional way, but I'm also doing it with looping, and then also using WebTask, which is a Auth0 serverless solution, which is interesting. I wanted to share that with you today because this helped me look at my code differently and come to a more elegant, or at least more readable solution. Again, I want to reiterate what has been said before today. We spend more of our time reading code than writing it. So let's make readable code that we can get through quickly and parse better and make better solutions. Thanks.